Mungu ibariki Tanzania, dumisha uhuru na umoja wake kwa waume na watoto. Mungu ibariki Tanzania na watu wake. Ibariki Tanzania, ibariki Tanzania, tubariki watoto wa Tanzania.
How are you, everybody who is watching this program? I would like to take this opportunity to welcome all the national, international, and the local viewers who are watching this program at this moment. My name is Olenjolai, Single. Simply you can call me just Olenjolai. I thank God by His own grace. I'm a local, a national, and international teacher. And I thank God who has given me a gift of teaching. So I'll be teaching you about advanced physics, advanced chemistry, advanced mathematics, and even basic mathematics for those who are studying. I would like to take this opportunity again to welcome you into one of our school that called the TANZANIA Online Advanced Secondary School in square bracket OLENJOLAIM. And simultaneously, I would like to welcome you into one of our official YouTube channel that called TANZANIA Online A-Level Secondary School in square bracket OLENJOLAIM. You are warmly welcome into departments of advanced physics, and the subject of the day is called the advanced physics, and we have a main topic called the electromagnetism, which is the first topic according to the syllabus of the United Republic of Tanzania. I dedicate this contest to all the pre-Form 6 students, Form 6 reciters, QT, grade 12, teachers and physicists who love physics. In electromagnetism, I say that we are going to cover 3 topics. It's the main topic, but we are going to cover 3 chapters. And the first chapter is called Magnetic Forces and Fields. And this is session 1, titled as Terminologies of Electromagnetism. So, when I will be teaching you in this session, I would like to just to give you some brief information concerning about how you interact with me, because always a class is not complete if students they don't ask you questions. So you may use the comment section below to ask you questions and to give me a feedback whether you have understood what I've been teaching you or not. Right? So that's a very important point. So let us go straight forward into our today's session. And let me start with quick review of session 00. So session 00, it has been titled as General Introduction. So general introductions of what? Of electromagnetism. So in that session, I've introduced it to you. First of all, I began with the big picture in my mind about physics. And then secondly, I've mentioned about the topics, 3 topics of what? 3 topics of electromagnetism. That's what I've presented to you. And these 3 topics have formulated them from 5 subtopics according to the syllabus of United Republic of Tanzania. So I've mentioned those 5 subtopics, I've mentioned the 3 topics of electromagnetism. Again, presented to you about specific objectives. Specific objectives of what? Of each subtopic. So the syllabus declared or mentioned the specific objectives that the students has to achieve when you are learning or when you are learning electromagnetism. So I remind you that one of the very important book is this one for the Tanzanian students that call the physics syllabus for advanced secondary education, Form 5 to Form 6. Very important book for all the students to have it in your hand. So that is all about what we have covered in general introduction. There's been a session of more than 1 hour. So in case you missed it, you can access it in our official YouTube channel that called the Tanzania Online A-Level Circuit School in square bracket OLENJOLAIM. You will get all of these important information which will give you the overview of what you have to cover as an advanced secondary student. All right? So today, let us start our today's session. Before I teach you about terminologies, 8 terminologies, because I've prepared 8 terminologies of electromagnetism, and these 8 terminologies, we are going to use them effectively in all the 3 topics. All the 3 topics, because I say that we have, just let me just give you a brief. We have electromagnetism. This is the main topic, electromagnetism. Then I say that we can break this main topic of electromagnetism into 3 topics. And these 3 topics, they don't have close relationship. They are still talking about electromagnetism, but in different perspectives. The first one, we say it is called the magnetic forces and fields. This is the first 2 topics that I told you. But another one is called magnetic properties, and what? Magnetic properties, we go to magnetic properties, magnetic properties of materials, magnetic properties of materials, magnetic properties of materials, and what? And magnetic fields, and magnetic flux density, magnetic flux density of S. And then the other ones is called the electromagnetic induction. Okay, so we have those 3 topics. Magnetic forces and fields means magnetic forces and magnetic fields. The second topic is called magnetic properties of materials and magnetic flux density of the S, or magnetic field of the S. Magnetic field of the S. Magnetic field of the S. And then the third topic is called electromagnetic induction. So you have magnetic fields and magnetic forces. Then we have again that one is called magnetic properties of materials and magnetic field of the S. Then you have electromagnetic induction. And each topic has its importance in learning the aspect of electromagnetism. So before we go into before I teach about terminologies, let me teach you about contents. What are we going to cover? Because when you say about terminology of electromagnetism, we are going to start with the first topic called magnetic forces and magnetic fields, or magnetic forces and fields. So we say that contents or concepts that we are going to cover in these first topic. Contents or concepts of electromagnetism. Not contents or concepts of electromagnetism. Contents or concepts of what? Of magnetic forces. What are we going to cover? Magnetic forces. Or what should you cover? And what in magnetic fields. Remember that the aims to mention all of this stuff is in order for students to be aware about the direction of this long time journey of electromagnetism. Magnetic forces and fields. So contents or concepts of magnetic forces of the fields. So the first concept that we are going to cover is called the terminologies of electromagnetism. Terminologies of electromagnetism. So these terminologies, we will find them in all the three topics: electromagnetism, electromagnetism, terminologies of electromagnetism. The second concept is called the magnetic fields. So I'll teach about magnetic fields. Magnetic fields. This is my extractions according to the syllabus and according to the past papers, especially for the questions, especially the paper 2 of physics. Then the third concept that I'm going to teach you is called the magnetic force. Magnetic force. Magnetic force. Then the fourth concept that I'm going to teach you is called the Fleming left-hand rule. We have Fleming right-hand rule and Fleming's left-hand rule. So in electromagnetism, we learn about the Fleming left-hand rule in this topic of magnetic fields and forces, but we'll teach about Fleming right-hand rules in electromagnetic induction. Left-hand rule. Then the fifth concept that we are going to cover is called the motion of the charged particle. Motion of the charged particle. Motion of the charged particle in a uniform field. In a uniform field. Then the sixth is called the torque on a current loop. So we are going to teach you how you can compute torque on a current loop. Current loop in a magnetic field. In a magnetic field. In a magnetic field. Then the seventh concept that we are going to cover is called the Biot. This is the name of the physicist. Biot-Savart law. So this is the law which has been experimented by these two physicists. These are the names of the two physicists. Biot, the name of the physicist. Savart is the name of the physicist. Then the eighth concept that we are going to cover is called the magnitude of magnetic flux density. Magnitude of magnetic flux density. Magnetic flux density. So magnitude of magnetic flux density due to a current carrying conductor. Due to a current carrying conductor. Then the ninth concept that we are going to cover is magnetic flux density. So magnetic flux density. Magnetic flux density, which in physics we notate it as B, magnetic flux density of a circular coil. Of a circular coil. Of a circular coil. Then number 10, we say that also we'll teach about magnetic flux density. Remember, B stands for magnetic flux density of axis of circular coil. Of axis of circular coil. Axis of circular coil. Then number 11 We are going to cover magnetic flux density due to, B stands for magnetic flux density. Magnetic flux density due to Helmholtz coil. Due to Helmholtz coil. Number 12. Magnetic flux density of the long solenoid. Teach about magnetic flux density of long solenoid. Long solenoid. 13th concept we are going to cover is magnetic flux density of toroid. Then the 14th concept we are going to cover is called the magnetic flux density due to a straight conductor. Straight conductor. 15. I'm going to teach about forces between two current carrying conductors. Magnetic forces. Magnetic forces between two current carrying conductors. Current carrying conductor. Current carrying conductor. 16. I will teach you about Ampere's law. 17. I will teach you about magnetic flux density at a point with Z with respect to two parallel conductors. Magnetic flux density at a point with two parallel conductor, two parallel conductors. Then in concepts, problem solving, we having intensive problem solving of magnetic forces and fields. So that is all about the first topic called the magnetic forces and magnetic fields. So these are the concepts that we have to cover in the first topic called magnetic forces and magnetic fields. So when I will teach about magnetic properties of materials and magnetic field of the earth, I will also mention the concept that we are going to cover. And when I will teach about electromagnetic inductions, I will mention also the concept that we have to cover. These are only for the first topic called magnetic forces and fields. Are we together? Okay. So make sure that you copy this. And another thing which is very important, you have to make sure that you get the copy of the notes of electromagnetism. For those who can meet with me physically, that's fine, you have it. For the online students, then you have to order it, and I will send it to you. Okay, so that's why that we have to start with the first concept called terminologies of electromagnetism. Some of the concepts are short, some of the concepts are a little bit long, so it depends. It doesn't mean that maybe you should have 18 sessions or whatever. So it depends. But one thing which I want to tell you, when you start to get from Bible Sabbath law onwards, at this point, From there, you'll start to experience how magnetism of advanced level looks like. There are so many assumptions. You have to know the derivations of the different formulas. For example, you have to know how to derive the formula for this concept. You have to know how you can derive a formula for this concept. You have to know how you can derive a formula for this concept. You have to know how to derive the formula for this concept. You have to know how to derive the formula for this concept. You have to know how to derive the formula for this concept. You have to know how to derive the formula for this concept. You have to know how to derive the formula for this concept. So each concept has its own formula. So that is what you have to remember. So we have conceptual issues and also we have mathematical issues. So we have theoretical concept and also we have mathematical concept. The only thing which I want to tell you, you have to be serious. If you want to cover about this topic and master it, it needs serious students. Okay, so before we go into the terminologies of electromagnetism, let me present the word itself. Or let me talk a little bit, or let me teach about the main topic itself, which is called electromagnetism. Electromagnetism. So we'd like to have a fundamental question. This is the fundamental question and it's common for me whenever I teach any new concept to my students. I used to start from the main concept or the big picture. What is electromagnetism? What is electromagnetism? Possibly you have defined this terminology in your O-level education, or you didn't get a definition, but it's better for you to know the definition of the term. Okay? Because you can be expert on solving problems of electromagnetism. But somebody can ask, what is electromagnetism? And hence you find, I just know how to write the formulas and use them. So just give me a question of calculation of electromagnetism, and then you see. Don't ask me a simple question like that about what is electromagnetism. Okay, so what is electromagnetism? So remember that for the online students, we'd like to teach you a method called active learning, where that you are allowed to try, right? You're allowed to try. Should not be a student who always receive things without even trying what is in your mindset. How can you try? For example, now I put the questions, what is electromagnetism? You can pause the video and then try to answer that questions on a piece of paper, the rough paper. Just answer what you are thinking about it. And then come back to check the corrections, whether you're right or you're not right. That's how we used to learn. That's the meaning of active learning. You participate in the process of what? Of learning. Because this is not a new term for you. We learned magnetism in physics before. It's the third topic in physics. If it's not, I think that's the second or third topic around there. But we learned magnetism in form 4. So this is not a new term. And even if it's a new term, so when you hear about this stuff and whatever, you can think something. So what is electromagnetism? You can say electromagnetism is electricity magnetism. That means, because this is a combination of the two words. Electromagnetism, electro means electricity, magnetism means magnetism. That is your thought. It's very important to have something in your mind. Okay, so the definition, you can go online or different sources or different books and check for the definition of electromagnetism. There are so many resources defining electromagnetism in different ways, but most of them, they have the same keywords. So I have found 3 definitions of electromagnetism. You may choose one of them. That might be maybe interesting for you or might be simple for you to remember it. But all of these 3 definitions, I found them in different reference books and different reference materials. So the first definition is this: Electromagnetism is a branch of physics. First of all, is a branch of physics. Is a branch of what? Is a branch of physics. Is a branch of physics involving the study of the electromagnetic force of the electromagnetic force and so electromagnetism is a branch of physics involving the study of electromagnetic force and a type of physical interaction and a type of physical interaction and the type of physical interaction that occurs between electrically charged particles. So electromagnetism is one of the branch of physics involving the study of electromagnetic force and a type of physical interaction that occurs between electrically charged particles. Every word is very important, more than you think. So before I explain this first definition, let me just present all the three definitions and then explain them together. Or some other resources define electromagnetism as electromagnetism is a physical interaction among electric charge. Among electric charges, magnetic moment and the electromagnetic field. And electromagnetic field. But the second definition or second way of defining the term electromagnetism. So, if you know a brief history of physics, in physics we have classical physics and modern physics. You guys, you're chatting while I'm teaching. And I've seen you several times. I've been quiet. So we have two branches of physics. We have classical physics. We have modern physics. So I'm asking you now, is electromagnetism classical physics or modern physics? That's the question that I'm asking you at this moment when I'm giving you the third definition. So electromagnetism is a process, some of the resources define as, is a process of producing magnetism, the process of producing magnetism due to the flow of electric current in a conductor. So electromagnetism is the process of what? Of producing magnetism from electric current which is flowing due to the flow of electric current in a conductor. So it's a process of producing magnetism due to the flow of electric current where in a conductor. It can be a solenoid conductor, it can be a toroid conductor, it can be a circular coil conductor, it may be a straight conductor, it means a straight conductor, it might be Helmholtz coil conductors. So we have different shapes of conductors that produce magnetism. Okay? So that's the meaning, or these are the three definitions of electromagnetism. You may go into different sources or different books of physics, and you can find even some other definition of electromagnetism, which might be a little bit different from the three that I've mentioned, but that should not confuse you. You have to get the point, you have to get the keywords, and then off you go. Okay, so let us move. Let me explain the first definition. Electromagnetism is a branch of physics involving the study of electromagnetic forces and the types of physical interactions that occur between electrically charged particles. So in these definitions, you can find these definitions is the subset of this definition. But in this definition, first of all, electromagnetism, it's a one of the branch. When you say it's a one of the branch, it's a one of the area of physics that deals with something else. And then this branch deals with what? Electromagnetic forces. So the word electromagnetism is a combination of the two words, electric and magnetism. Right? So this is dealing with electromagnetic forces. What does it mean? Magnetic force and electric force together. But it does not only deal with electric force and magnetic force, but also it deals with physical interaction. Physical interactions between what? Electric field and magnetic field. But where does this occur? This will only occur in electrically charged particles. What do we mean about charged particles? It means that a substance which will experience electromagnetism should have something we call charged, or should have something we call them charged particles. So these charged particles are the one which can create or produce magnetism from what? Electricity. Are we together? So that is explanations about the first definition. The second definition, electromagnetism is a physical interaction. So you see again, still explaining the first thing, is the physical interaction among electric charges. So you see the relationship between the first definition and the second one. Electric charges, magnetic moment, and what? Electromagnetic field. So when we say physical interactions, we have electric field, we have magnetic field. That's why that we had a phrase, which I even myself I heard when I was in O level. Whenever we have electricity, there is magnetism. And whenever there is magnetism, there is what? Electricity. Right? What does it mean? It means that electricity can produce magnetism from electricity. The meaning of electromagnetic inductions is producing electricity from magnetism. So these definitions, all of these three definitions will be focusing on how we can produce magnetism from electricity. Are we together? So that's a simple meaning. Electromagnetism, whenever you hear the word electromagnetism, producing magnetism due to the flow of electric current. Whenever you hear the word electromagnetic induction, it means that producing electricity from what? Magnetism. Are we together? The third definition, this defines that electromagnetism is a process of producing magnetism due to the flow of electric current in a conductor. So this one it actually gives us the definition or the meaning or the summary of what I've been explaining to you. Okay. But another question, up to this time, have you realized or have you noticed one of the applications of electromagnetism in our life? Because simply say that we have interactions between electric fields and magnetic fields. Do you know one of the real life applications of electromagnetism that you are using every day? The answer might be yes, or the answer might be no. But whenever you hear any radio broadcasting or any television broadcasting, that is all applications of electromagnetism. But anyway, some of the students and some of the people, they might say that we don't watch TV and then we don't listen radio. That's fine. Let me give you one of real life applications of electromagnetism. Whenever you communicate on the phone, you are applying electromagnetism. I think that from that point, for the students who are in vacation, they understand what I'm telling, because they always communicate with their parents, their relatives, right? So when you're doing, we call it, whenever you're doing even the internet, maybe cellular, it means voice communications or any mobile communication, you're applying what you're applying electromagnetism. But maybe for the internet, many students say that we don't have money to buy for the band. Anyway, but to make a call or receive a call, that is something students, even students of advanced level, they enjoy every day. So let me tell you where. Whenever you see any telecommunication tower, when I say tower, do you understand? Any communication tower in your street or nearby the place where you're living by, right? That telecommunication tower contains antennas. Those are not drums that maybe you can produce a sound. No, those are the antennas. So there are different types of antennas. So when you make a call, for example, or when somebody calls you, in order for you, or in order for that phone or that call to give you notification that somebody is calling you, you should be in the network. And that network is what we call the cellular network. And that cellular network, it means that any nearby telecommunication tower will be communicating continuously with your handset. Okay? With your handset. So for instance, if somebody is talking and then you are hearing on other sides, or when, for example, yourself that you are making a call, and then you are making a voice call, right? Your mobile phone will have a microphone. It will receive what? To receive sound wave, okay? Or your voice will be in form of the sound wave, which is mechanical wave. And then we say that your handset conveys that sound wave into electric wave or into electric signal. And that electric signal will be processed on your cellular or on your mobile phone. But before it exits from your phone, it has to be converted from electric signal into electromagnetic signal. Why? Because every cellular or every handset has something we call it antenna. I think most of the phones nowadays, they have inbuilt antenna. If your phone does not have an antenna, you cannot communicate and you cannot access the network. So the antenna, it's the one that propagating your sound signal into the nearby telecommunication tower. How is it propagating? It means that an antenna has ability to convey electric signal from your mobile phone into electromagnetic signals. And that electromagnetic signals will be propagated with the speed of light to the nearby telecommunication tower. And then that telecommunication tower receives that signal and converts it into sometimes in optic form in order for it to be transmitted fastly through the fiber network. So that's the simple applications of what? Electromagnetism. Are we together? So regardless of the change of the technology, electromagnetism will never be phased out because it's very important. Again, another way that, for example, how many of you have what you call the telecommunication dish? You have a dish at home, right? That dish is receiving electromagnetic waves. Okay, it's receiving what? Electromagnetic waves from what? Transmitter of the particular, maybe television, television, maybe for example, I think that you like other, right? So other, it means that it is located, most of the transmitters have been located in Kisarawe. Okay, so it means that the dish, your home dish, your television set means that your television dish, receiving dish, okay, is actually receiving what? Electromagnetic waves. And that electromagnetic waves will be converted into electric signal. And that electric signal is what will be received or processed in the television, television receiver. Okay? And then something else will be going on there until you see a picture and you hear the sound. But that picture is due to the electric signal has been converted into light signal. You cannot see electric signal. What we see actual in televisions, okay, in televisions we see light. That's how. So you can understand now the importance of the principle we learned that of principle of energy conversion. Energy cannot be created more straight, but can be from one form to another. Okay. So I have tried my level best to open your mind or to share with you about real life applications of electromagnetism. So what we are learning actually, we are not learning for luxury, we are not learning for just for leisure, but we are learning something that we are applying in our daily life. If there is any question about definitions of electromagnetism, you're warmly welcome, ask it. If there is no any question, you're welcome.
Some question.
Okay, you're welcome.
On the application for electromagnetism, you say that the electromagnetic waves can be converted into electrical signal.
Yes.
There are any instruments that is used for the changing of the form of the electromagnetic waves to electrical signals.
You said that you're asking, is there any particular instrument that's converting from electromagnetic waves into electric signal? Yes, the good example is an antenna. At your home, do you have a dish? You have a dish here. So that dish is receiving electromagnetic waves. Okay, that traveling with the speed of light. Okay, and then your television receiver does not know anything or cannot process any electromagnetic waves. So that's why you have that dish, which have a capability to convey electromagnetic waves into electric signal. So that the electric signal can be processed by your television receiver. But again, remember that if you have a television receiver without a screen, can you see what is going on in the motherboard? No. So it means that the electric signal has to be converted into light signal so you can see the picture. At the same time, on the sound part, that electric signal should be converted into sound signal so you can hear. If you want to understand what I'm telling you, go back. When you go back today at your home, take the screen and take it out, and then take the speaker of your television set, and then sit there and wait the picture and the sound. Well, I think that will be a good experiment. Terminologies of electromagnetism. Students say that, my mother will punish me. Electromagnetism. No, you tell mother, I'm doing an experiment. Today I've been taught this concept, so I want to prove it. Okay, so I'm going to teach you 8 terminologies of electromagnetism, and I'll teach you in a different style because these terminologies are very important and we are going to use them effectively. So that's why I want to build the foundation for these terminologies. So In the next sessions, we'll just recall and then keep on moving. The first terminology is not new for most of the students. It's called magnetic poles. So magnetic poles. Magnetic, say with me, magnetic poles.
Magnetic poles.
Say again, magnetic poles.
Magnetic poles.
So we have magnetic poles. So then we have a question here, which is, what is magnetic poles? What is magnetic pole? So we say magnetic poles. We know that we have north pole, south pole. Magnetic poles are the regions in a magnet where magnetic fields are highly concentrated. Magnetic poles, so poles plural, are the regions in the magnet where magnetic fields are highly concentrated. The magnetic fields are highly concentrated. Where magnetic fields are highly concentrated. So I say the magnetic poles are the regions in the magnet where magnetic fields are highly concentrated. So I say that a magnet has two poles, namely north pole and the south pole. Namely north pole and south pole. And we used to draw them so that you have two poles. Yeah, so you can have a bar magnet like this. So north pole, south pole. That's the first terminology, which is not new for most of you. But we have again another terminology which is very important. This is called magnet. So the fundamental question is, what is magnet? So magnet is a substance or material produces a magnetic field. Magnetic field. Or a magnet or the magnet is a substance which shows which show magnetic properties and attracts magnetic materials. So a magnet is a substance or material. What's a magnet? A magnet is a substance or material, produces magnetic field. Magnetic fields in plural. Magnetic fields. So a magnet is the substance which produces only magnetic fields. Are the main functions of the magnet. Or some other sources, we find that a magnet is a substance which shows, so still a substance, which shows what? Which shows magnetic properties and what? And attractive magnetic materials. It shows magnetic properties and also attractive magnetic materials. And the meaning of the magnet. And if you do remember that we said we have two shapes of magnet. We have a bar magnet. The other one is what? What the next shape? Horse magnet. So another shape is horse magnet. Like this. So still have North Pole, South Pole. So this is bar magnet. And this is horse magnet. Okay, so that is still a simple terminology. Second simple terminology. So the third terminology of electromagnetism is called the magnetic field. Magnetic field. Magnetic field. So we have a fundamental question. What is magnetic field? What is magnetic field? So, magnetic field is vector field. Is vector field that describes magnetic influence on moving electric charge. On moving electric charges. Electric current, remember the word magnetic field is one of the terms that we are using in this topic. So magnetic field is a vector field that describes magnetic influence on moving electric charges or electric currents and magnetic materials and the magnetic materials. Magnetic materials. Or, in other words, magnetic field is a region surrounding a magnet. Is a region surrounding a magnet. It's a region surrounding a magnet whereby magnetic force, whereby magnetic force is experienced, whereby magnetic force is experienced. So, magnetic field is a region surrounding a magnet whereby magnetic force is experienced. So, what is magnetic field? Magnetic field is a vector field. What is the meaning of vector field? In physics, or the first topic of physics form 3 is called the applications of vectors. So magnetic field is a vector quantity. It's not a scalar quantity. So magnetic field is a vector field that describes magnetic influence. So what it means of influence means that displays magnetic force, magnetic influence, okay, on moving electric charges. So what it means of moving electric charge? On moving electric charge, this means what? Because we can have stationary electric charge and moving electric charge. So stationary electric charge, it means electrostatic or static electricity. Moving electric charge means that what? Current. So current is moving an electric charge from one point to another point. Or it can be caused by what? Electric currents. So it can be caused by electric currents and magnetic materials. So these magnetic fields can be produced by moving electric charges, or by electric currents, or by magnetic materials. So this is the vector field that describes magnetic influence. What it means of influence? Influence means power, right? Or ability. That means of influence, right? For example, if you say that if you want to be influential person, or if you want to be influenced, a person of the influence in our community, it means that if you want to be a person of a certain authority or the particular power, then you have to 1, 2, 3, 4. Or is a region surrounding a magnet. So magnetic field, it's a region surrounding a magnet, whereby magnetic force is what? Experienced. And this magnetic field, because you have magnetic field and magnetic field lines, the magnetic field is not seen by the naked eyes. But if you bring something else near to that place, you will see there is a particular force, or there is a particular influence. For example, if you have a magnet and then you bring a coin or a piece of iron near to the magnet, it will be attractive. What does it attract? What does attract that piece of iron?